People with hemophilia start life with normal, healthy joints, but bleeding into the joint causes damage. Blood in the joint space can induce joint disease. To understand why, let's start with a healthy joint. Synovial joints are encapsulated by a fibrous sheath of dense connective tissue. The inner side of this capsule is lined with a membrane called the synovium. Cells reside in the upper layer of the synovium. In the lower layer is a network of capillaries that supply oxygen to the joint capsule. The synovium generates fluid that lubricates the joint, allowing for free movement. The ends of the bones that come together in a synovial joint are covered in a thin layer of cartilage, which is made up of water, electrolytes, and a solid matrix of collagen and proteoglycans secreted by chondrocytes. Bleeding into the joint capsule, or hemarthrosis, triggers a number of different processes. Blood and its breakdown products in the joint capsule lead to synovial cell proliferation, synovial hypertrophy, and reactive blood vessel formation. Macrophages from the synovium remove blood products from the joint to repair the damage. Exposure of cartilage to blood components, particularly iron, leads to damage. Changes are usually transient and generally reversible, provided the bleed is small, but permanent cartilage damage may occur after the first hemarthrosis. Repeated bleeding into the joint triggers hypertrophy, hyperplasia, and hypervascularization of the synovium, increasing the propensity for further bleeds. Iron accumulation, inflammation, and hypoxia are believed to drive these processes. Iron from the blood is taken up by synovial cells and eventually forms iron storage complexes called hemosiderin, overwhelming the ability of the synovium to absorb breakdown products and transfer them to the general circulation. Iron activates MYC, a growth-promoting transcription factor, and induces MDM2 gene expression that decreases apoptosis, causing synovial cell proliferation. Iron also causes the production of inflammatory cytokines, including TNF-alpha, interferon gamma, interleukin-1 and interleukin-6, by synovial cells and infiltrating inflammatory cells from the circulation. And the inflamed synovium also produces matrix metalloproteinases. The inflammatory cytokines further increase iron uptake into synovial cells and stimulate synovial cell proliferation. An increase in intracapsular pressure from bleeding, proliferation of cells in the synovial membrane, and its infiltration by inflammatory cells create a hypoxic environment. Hypoxia induces pro-angiogenic factors, which leads to increasing vascularization of the synovial membrane. Collectively, these processes create a condition known as synovitis, characterized by a chronically inflamed, highly villous, overgrown synovium that is extensively vascularized with weak and permeable vessels. The synovium now occupies much more space in the joint capsule and is very susceptible to injury, contributing to further bleeding. Hemophilic synovitis naturally evolves into fibrotic scar tissue, beginning with fibrous adhesions formed by clots remaining in the joint space. Physical and biochemical changes in the joint with repeated bleeding also cause cartilage damage. Prolonged exposure to blood, cytokines, and proteinases released from the hypertrophic synovium result in cartilage degradation. This appears to be mediated by a decrease in proteoglycan synthesis and increase in its release from the cartilage matrix. Interleukin-1 beta from synovial macrophages increases hydrogen peroxide production by chondrocytes, the cells responsible for synthesis of the cartilage matrix. Iron catalyzes the formation of hydroxyl radicals from hydrogen peroxide, causing oxidative damage that leads to chondrocyte apoptosis. Because chondrocytes proliferate at very low rates, this can cause long-lasting and irreversible damage to the cartilage matrix. As blood-induced joint disease progresses, bone remodeling also occurs. Osteoclastic, but not osteoblastic activity increases, likely in response to changes in the expression of proteins that regulate the differentiation and activity of these cells, resulting in reduced bone mineral density and ultimately osteoporosis. Joint arthropathy resulting from repeated hemarthroses is characterized by joint stiffness, chronic pain, and severely limited range of motion that limits mobility and diminishes quality of life. Although one hemarthrosis causes pain and swelling that resolves, the damage is cumulative and can ultimately produce hemophilic arthropathy, with debilitating and disfiguring consequences for young patients. Vulnerability varies, so it's not possible to predict the impact of hemarthroses for an individual. Even just one serious joint bleed can result in lasting damage for some people.